Welcome back to the Integrate Intelligently podcast. I'm Jeff Brickler, your host, along with my brother Scott Brickler again, as CADtalk CEO and founder. So welcome back, everyone. It's been a bit, we're back in the office today having another educational conversation about CAD and CAD integration and ERP and PLM. So today is a special episode 19. Scott, we're talking about, getting your CAD and ERP talking rather than linking, right? So today's a special episode talking about, of course, the big difference between CADtalk or the thought of getting your systems talking versus, linking two things together. So looking excited to talk to you again about these topics, kind of a niche topic itself, but, it's our own personal nerd. So I'm looking excited about it. Remember that we're talking about CAD, PDM, and PLM systems, so engineering-based systems, and ERP and PLM systems, for manufacturing companies. Before we begin, we want to remind people, why is integration important? Integration can be important in terms of its speeding efficiencies, improving the process, getting consistent processes in place. We all know that for something to get better, it has to be consistent. To improve it, it has to be consistent. And, integrating your systems, getting them talking definitely makes those possible. So first things first, Scott, any thoughts? It's another Wednesday, just past election day. So we were out of town last week. So how are things?
Oh, things are wonderful. I think it's been a fun couple of weeks. I mean, we did some travel, got to do some fun things, got to go to the SaaScam event we talked about last podcast. It's been a really exciting and fun couple of weeks, and just really looking forward to actually got some fun, exciting things going up in the future too. So really interested in getting into this topic because I think it's definitely a deep dive, which I think is a great format for us. I think there's a lot of customers or prospects or people who are just interested in this topic that really want to understand the idiosyncrasies and the deep knowledge about how this stuff works. And I'm really excited about getting into this, getting in the weeds a little bit and talking about this type of stuff.
Yeah, I noticed that when we do these topics where they're very technical or more technical, right? What is CAD or what is PDM or what is PLM? We get the audience seems to have a go up, right? We have a better audience, better engagement. So I'm excited to talk about this. Get in, as you said, like really get into the weeds or the niches of this, what we're doing. I think, having been a teacher, I like to educate, and I think it'd be great to educate folks on the topic, what we know best, what you've been doing in some form or fashion since the late 90s, right? The original idea. And for me, I've been working on for nearly a decade now. So let's get into it, Scott. So tell us a little bit about, I think maybe even when you first came up with the idea or thought about it, tell us a little bit about, what the idea of linking your CAD system or what are your thoughts about that? I mean, was that the original idea or what did you think about versus talking?
I mean, I think that linking is actually the most intuitive way to think about the problem. It really is. I mean, if you think about, like, I have these systems and your first thinking, or your first thought, like, especially if you're an engineer, is like, well, I created this thing, I created this design, and now we have to get it into this other system to get it made or whatever that is. So I need to, and I want these changes to kind of pervade, like persist to the other system, right? So if I changed form, fit, or function, or I change the design, or I change the description, all these things just kind of synchronize all the way down the chain. And therefore, I'm only working with like this one idea of what's the master data, right? And the master data being, who's the owner of the data. And it's very intuitive that it makes a lot of sense, right? You're thinking, okay, well, it's the same data. I mean, this is your initial thought is it's the same data. So therefore, why don't we just link these things together? And then so the very first versions of CADtalk we built kind of worked that way. It was kind of like, especially version 1, version 2 kind of had this concept of like, it's a shared common data, like the data from the CAD or the data from the PLM was shared with the data from the ERP. Like there was common fields, like a description or a part number and things like that. And then those things should kind of like, when you change one, it should change the other and things like that. It makes a lot of sense. But the third iteration of CADtalk, when I looked at the problem even closer, it was actually more subtle than that. It really wasn't necessarily linking. It was more like a transformation. So almost like a derivative. And so the data coming, and I think the better way to look at it is today, which is how we look at it, is that the CAD data or the engineering data is the base of and the derivation of that is the ERP or manufacturing data. So it's not so much of like, I'm going to take this and move it from here to here and link it together. It's more of this concept, I'm going to take this data from here and transform it into something else. So to like tie them together or to link them is kind of like tying apples and oranges. They're not actually the same thing. One it's derived from the other. Maybe like better example would be like apples and applesauce, right? They're not exactly the same thing. They're applesauce consists of apples, but it also has cinnamon and other ingredients in it too, right? So the same thing.
Good applesauce does, at least. The good applesauce has the cinnamon and the sweetener
stuff, right?
too.
Exactly. You got it. Right. Maybe a little maple syrup, something good, right?
Yeah,
so,
something good.
Yeah. So yes, it consists of apples, but it's not apples, right? It's not just apples. So that's kind of like the idea of, engineering data and ERP data, right? So linking becomes actually really restrictive in that world. So let's just use an example of like the one that everybody always talks about is description. That's the one that description and part numbers are the ones everybody wants to link, right? Well, description, it's like the description needs to match from here to here. And you're like, well, sure it does. But like, let's just go with a simple example of like, maybe in like SolidWorks, the description can be as long as you want it to be, right? It could be almost infinite, right? I mean, it's not likely not to be, but it could be really long. But there's when you go to an ERP or PLM, there's field length restrictions, right? So what happens if your description in SolidWorks is 100 characters, and your description and field that you have in your ERP is 50 characters? What do you do? Well, by definition, they can't match, right? So you can say, well, if I link them, then I have to make a decision on whatever the lowest constraint is. So the lowest constraint is that the description can only be 50 characters, therefore I got to make it 50 characters in SolidWorks. But you're like, well, wait a minute, there's like, couldn't I add a custom field inside of the ERP that has like an extended description? Then take the description, but then you're like, well, if I'm linking, I got to have an extended description now in SolidWorks to link it to. But if I have this idea of a transformation or just the fact that they're talking to each other, that's hence the talk name, right? Talking to each other, then I can do something like take the description, the single field or the single data point in the CAD, and transform it into two data points or two fields in the ERP by being able to enable so even though it's the same data, they're being transformed into two separate areas. So because we're dealing with two different things, the apple and the applesauce, right? As opposed to saying, well, we're gonna make them both apples so we can sync this. But description's really one of the few cases where it actually even you really, really want it to sync, right? And you could make that decision. Well, that should absolutely sync, so we'll just tie it together. Then you could, right? But that's really the only example that maybe the part number. But once you get after that, then there's like all this other data too. Like there's data that you could derive from the engineering, but not necessarily stored in the engineering. Especially things around routings and things like that are more manufacturing based or vendors. That data could be kind of embedded in the logic of the design, but it doesn't necessarily need to live in the design, right? But you could derive it from the design. And it's actually better suited to live in the ERP side. So that transformation also allows you to do things like take this genesis of data and then make assumptions or rules around how it turns into something else. That way you don't actually have to store the data in both places. Linking assumes the data has the same in both sides. But the transformation allows it to be, I can actually derive the data from a source data. So therefore you're not trying to keep two pieces of information synchronized. You're literally deriving the information again from the source to the destination. So if I were to change the design, let's use an example of a routing. If I could look at the features of a design and figure out like from the features of that design that it needs to go to a laser and then get deburred and then maybe go to a press brake, I can just derive that from features in the design. Do I need to put literally the routing steps into the design to do that? To link, I would. To talk, I don't. Because I can actually take those features that are already built into the design and derive the fact that it needs to go to a laser, into a press brake, into deburr. And if they change the design, those features change, this then changes my derivation, as opposed to trying to keep the data up to date in both places. Completely different way of approaching the problem. Does that kind of make sense?
Yes. So I have two ways that I explain this. And of course, you and I come from different backgrounds. I haven't been a teacher and you from a very engineering centric background. And it does make sense, right? That often when I tell customers and when I worked on projects, tell customers to do that, give them tips on ways in which we can automate and transform. The one way I was expressing it earlier today was like kind of two Venn diagrams of data sets. You have one on the left and one on the right. Maybe in post we can have these Venn diagrams, and you have in the middle like a Venn diagram, like you have overlap, but then you have all this other stuff on each side, right? That's not related or that's not linked together, right? There's not a one-to-one comparison, but you have maybe some stuff in the middle, right, of the Venn diagram that is the same. Like to your point, could be description, may not be, because sometimes you have different countries, different languages, and maybe you might have more complexity, or you might need to combine things from the CAD into a description. So that idea that you're going to have a one-to-one relationship might not be there. So that's Venn diagram, that overlap can tell you a bit better. Even like quantities, which you might think overlap, that's not always the case, right? Because you may phantom parts, or you may change the way you do it in the ERP, so that Venn diagram may or may not have very many things in between. And where I think about, like, you're linking two things together, that assumes kind of one big circle, right? Like the things over here and the things over here, they're on top of each other. They're the same. Similar to like, I have two CRMs, and one's they're called customers, one's called clients. Well, the client name and the customer name, that's the same thing, right? Mm-hmm. It's the easy. It's going to be a first name, last name, right? Or I'm going to have an address and number and street name, and then apartment, and there's form fields just you see when you fill out the websites. Like that's all stuff like that makes sense because it's the same data, the same language, if you will. And having come from a language background, I think of the same thing, right? Like that in English and Italian aren't the same language. You might share words that are the same, but one language does not speak the other. Just because gelato and tiramisu and pizza does not make you an Italian speaker.
Right, exactly. And the other caveat to that is that the linking could actually restrict flexibility, right, in a lot of ways, because I think this happens a lot. We talk to customers, they implement, they go, well, what data do I need to put into my CAD to make this work? Because they're already doing that Venn diagram thinking that you had of making them the same, right? They have to be the same. So anything I need over here has to be over here. And that's actually not true. If you assume a linking, it is that is kind of that's because it's like I said, it's the most intuitive way to look at it. Like I'm going to link the two together. Therefore, anything I need to put over here, I need to have over here. But then I think it blows people's minds a lot of times when we talk to them. They're like, yeah, is there any value in having that data over here? Well, no. Can I figure out what that data should be over here from this? Yes. Then why actually add anything extra? And that opens up another layer of it actually simplifies things immensely, because then you're only putting the data in that you need for that role. Like the ERP needs this data and the CAD needs this data. So people always like, who's the master of the data? I said, what's the data? Like it doesn't matter. Like the master is different depending on who the data is, right? So if it's design data, it's the CAD. If it's manufacturing data, it's the ERP. Like that's, and I think people always try to get to this, like, who owns it? Who owns it? It's like, it depends,
it does.
It depends,
Yeah, I think we talked about this in the previous episode. It's like that master data concept. Who's the master, and who's the source? What's the master? And I think we talked about like, well, it depends on the data, right? Who is the master? Now that the data overlaps, you might have a master where you have like descriptions might be one of those things, maybe not, right? But you had to decide who the owner of that data is, right? Like MRP related data or ERP related data, or even PLM related data, like the vendors and that sort of thing may only be there, right? That's the master. The list of what vendors you can use, or the suppliers, or the list of raw materials that you can use may be in that target system. And that may be the master, but like what kind of material that you need to use may be, like whether that's 304 stainless or whatever that is, that may be the engineering prerogative, or like what the tolerances of this part are, or those are engineering specific. And he owns or she owns that data. So there is no one master, if you will, a data holder. It just depends on what the data is.
Yeah. And so I think that the idea of this kind of the Venn diagrams is a great one, or the idea of the derivative type of thing of like this, the data starts here, then it drives into this, and then it drives into this and then a change here in this pipeline of data flow a change here would ripple down the line. So I think a lot of times we actually got to ask a lot of questions about, like, if I change the description, or the description is always the one that comes up. If I change this data in the ERP, does it go back and change it in the CAD, or does it go back and change it in the source? Well, first of all, if the data isn't in the source because it isn't relevant, then no, why would it need to? But if it is, then if it's actually there and it's relevant, then you want to start where the source is, not where the end is. So if description matters, this is a kind of a controversial statement, but I'll take a stand on this. It's like, people really beat us up on it, like, not beat us up, but people ask about a lot about descriptions. And it's like, well, I want to change the description over here. Does it automatically change it in the? I was like, well, if it matters, then that technically is an engineering change, right? You're changing the design. If it doesn't matter, then what is it? Then why do you want it to go back? Right? Like, if which one owns the data, right? So if there's a reason why the description is the description, then we should have done that during. So to me, it's always like, you make a conscious decision as an engineer to change that thing, and then it flows back through the process to the manufacturing, things like that. If it matters to engineering. If it doesn't matter to engineering, don't put it there. It matters to manufacturing, then start there. And then don't bother to put it in the other one, right? So description is really the only one that you usually get a lot of debate about. Most people are, if you talked about like work centers or other data that the engineer doesn't care about,
it would be
no debate. There's no debate. The description is like the one that everybody goes back to, that really people worry about. Part numbers too, but even part numbers are sometimes even are less argued, or less political, or as
less contentious.
Yeah, it's contentious than the description.
I mean, because I've had customers where implementations where, like, I have an engineering number, and then we have an ERP number. And the example I always would give is, like, I have like CAD 1, 2, 3, 4, and that becomes ERP 1, 2, 3, 4, and that helps us to differentiate, like, the different numbers, and that way they don't clash, right? We don't ever have clashing or whatever. And I've done implementations like that when I was doing implementations, and totally makes sense. It's like, yeah, you can do that transformation of CAD 1, 2, 3, 4 to ERP 1, 2, 3, 4, and a perfectly acceptable way to do it. But you can't do that if there are two things tied together. But you're right, descriptions are the most contentious kind of thing. People are like, why? These have to be absolutely the same. I know that I've had customers and partners and people tell me, oh, they absolutely have to be the same. It's like, well, what happens if someone downstream in manufacturing changes that? Okay. Now sometimes now the question comes up of, well, if they change it downstream and engineering didn't, is engineering going to overwrite their changes? And then that's the beauty of the transformations. You can then decide whether they can do that or not. You can say, no, if the engineer puts the description down and it's just a placeholder as a place to jump off from, to add to, then he puts his part in there, and then downstream manufacturing or document control or whoever can add to it. And then next revision comes up, we can say, no, don't, if the item's there and description's been enhanced, leave it the same. Don't mess with it.
Yeah. And I think, it really comes down to, like, people are really what they're worried about with descriptions specifically is, like, I create a paper drawing of this engineering design, and the description on that drawing needs to match the description that comes out of the paperwork, necessarily from the ERP, like for like a traveler or something like that. And that's where they get. And then it comes down to, like, well, what's going to happen if that happens, right? It's like, what's the fear, right? And or the concern. And if it's part number, ERP 1, 2, 3, 4, and the part number that on your drawing says ERP 1, 2, 3, 4, and the description is bracket, or the other one is flange bracket, is it going to change the world that happened? No, it's not going to make any effect. Now, if it says bolts and the other one says flange, then you're going to be like, well, why is that different? Like, that's weird. Then you're like, well, because we reused a part number, which is a completely different problem. Synchronizing them and linking them won't fix that.
Right.
So it's like, it's a bigger problem than that. I wonder if it's not, and I'd be interested in seeing the comments on the videos. This is where, like, really kind of taking a stand on something. I mean, maybe we'll learn something new that I didn't know after 20 years. I mean, it's possible, not being, it's just like, but what's the fear? I think the fear kind of, or the concern, harkens back to a time before computers in some ways and how things used to be. Right. So it's like, well, these descriptions is how we found things in the past and how we knew what they were. And now we use part numbers and attributes and databases to figure that stuff out. So the descriptions, albeit important, aren't like they used to be, right? So, but there's still this throwback of the concept that they have to be exact and they have to match and all this type of stuff. The really thing that only has to match is there has to be a way to decide that this thing that I designed, I identify it somehow, and I can identify it again on the manufacturing side when I change it, which we typically do by some kind of a part number, not by a description, because a description is unreliable. It's subjective. It could be like I said, flange or bolt flange. A part number 1, 2, 3, 4 is always 1, 2, 3, 4. And that's what we tell people. It's like you have to know if what you're creating is either new or existing. And the only way to know that is to have some unchanging thing that identifies the item that you're building. So either through a link of a part number to a drawing number, or the part number itself that says, this is this unique thing called this. And that gives us the idea of, is it new or is it changing? That's the only way you can know. The description is unreliable. And I know it probably sounds like I'm like these are things I'm passionate about, because it's like we have an opinion about this, like how it could be done, and like maybe our opinion doesn't match everybody's needs. That's fine. I think it's better to have opinion and go forward. But I think the CADtalk itself is flexible enough to deal with lots of different ways of doing things. But in general, just working with hundreds of customers and thousands of customers over the years, these are things that we've seen work the best in our experience. And it makes things more seamless. And this gives us the most flexibility for most manufacturers to work with. And everything else we've seen tends to be more restrictive.
Yeah. So like, that's a good point you make about restrictive. And I go back to my kind of language thought with talking and communicating, is that you don't, like when you're doing an integration, right? And you have the different systems and they have different data sets and they have different needs, right? In terms of like what engineering needs versus what manufacturing needs, or even what PLM needs. You need a way, you need something that can be intelligent and can figure out what you need. Having just copy the data from one place to another may not be what you need, right? May not be a solution for you, because now you still have to have a lot of a manual entry, because you're bringing over data. You're saying, oh, I got this data from my engineering, but I really need it to be transformed in some way. With CADtalk or talking, I think about like translation or communication and intelligence. It's adding value where you need it, as opposed to tying the two pieces together.
I mean, you keep on with that kind of analogy of like, think about like idioms that people say in the English, and they were being translated to Italian, right? You would say like 6 to 1, half dozen to another. If you could literally say that in Italian,
it wouldn't mean the same thing,
and nobody would understand what you're talking about. But if you could but if a person who really knew how to speak in both languages, or talk, we'll use the talk kind of analogy or term for that, they would say, oh, I understand what he means. And they would use the idiom in Italian.
That's right.
And that is the ultimate flexibility.
In Italian, you have this concept, like in the mouth of the wolf, where you're like, you're in the mouth of the wolf. That's like good luck, right? It's kind of like our break a leg, which you wouldn't say in English, right? In English, you say I'll break a leg, but in Latin or Italian, say something else. And Latin has even more. So every language has its own idioms, its own way of communicating the idea of what you're trying to achieve. And I think it's the same thing with engineering and manufacturing, right? You're trying to convey the idea of what you're trying to achieve, but you have to do it in the language in which you know.
In the language of the destination.
That's it. Yeah.
Yeah. And that's the part that's like, that's where over time we realized that the linking painted you in a box of that it made some things easier. The bidirectionality of like, I'm going to copy the description back and forth. That was easier with linking. Absolutely. But it solved that small problem and it created a lot more bigger ones. And by removing flexibility. So our philosophy is always around more flexibility, as opposed to more like flexibility and the ability to transform and having the kind of idea that these are not the same data. One is a derivation of the other, and they all have and the reason why we have two different systems that we're trying to integrate is because those systems have completely different roles in the organization. Otherwise, if they were the same data with the same role, then why would we have two?
Yeah, that's it. Yeah, that's a good point. Why do we have two different systems if they're the same thing?
Yeah, and so
they have different use cases, different needs,
different needs, right? Yeah. They're different languages.
That's it. That is a good analogy. I didn't ever thought about that. Why do we have two different systems? Because they do different things. I explained to somebody earlier today, just because you share the same word does not mean that you speak those both languages, right? Because you say cappuccino does not mean that you speak Italian now, right? Just because you say pizza does not make you Italian, right? Just because you say like carpe diem does not make you knowledgeable in the Latin language, or you or if you have some Greek phrase tattooed on your back, right? Or whatever, right? Does not make you a language that fluent in
Doesn't
that
make you a
language.
Spartan. Doesn't make you a
Yeah, it
Spartan.
doesn't make you a Spartan, right? Yes, right. What is that Spartan phrase like you about your shield? Yeah,
Yeah.
that's pretty popular now. Yeah, it doesn't make you a Spartan. So as much as we hope it did, so that's good. They're two different things, right? So got to treat them as that, and I think that's gets into the CAD talk and talking. I've done lots of projects, and I could talk to a little bit about like how talking has helped customers to like achieve the goals that they wanted. But how about you, Scott? Like, what are some real world scenarios? You mentioned, you talked a little bit about them where like the talking solved a problem, like a complex problem
Yeah, I think that
that like linking wouldn't solve.
yeah, I think that like the ability, I mean, obviously the ability to do transformation, which is what we talk about with talking, right? Like almost interpreting or talking. We use that. That's actually intentional. The name of the product is intentional for that reason. Another great example of that is like just differences in data structures. I mean, to get really techie with it, like the way CAD represents data isn't the same as the way ERP represents data. Raw material is a great example of that, right? So raw material in the CAD world is like a property. It's an attribute of something. Like it's like I'm making this part and it happens to be made out of mild steel. In the ERP world, that's actually a subcomponent. It's like I take this raw material and I apply an operation to then make this other part. So there's a part number, 1, 2, 3, 4 turns into 4, 5, 6, 7, 8 when I apply a laser to it. But I have to know, so what tends to be like an attribute or like almost like an attribute of the part in the CAD world actually turns into a subcomponent in the ERP world. How would you link that? Right? You have to like one's at like the level of the part number itself and one's at the level of submaterial. And then how do you get the other information about it, like the quantity, right? That's actually not, there's no field called quantity. I mean, you can have a material quantity field or something like that you put into the model, but that's actually driven from to a dimension in the model, right? The size, square inches, something like that. So no matter what you do, there's a transformation just even in the data structure. The data is the same, possibly, right? Maybe they had the same part number in there for the raw material. A lot of times they don't, but they say they are. Then the quantity is still the same, but the way that it's structured in the data is different. Therefore, still requires a transformation. So they're having the flexibility to do that, to turn what we consider to be a property of something into a sub item of something. That data structure change is also what talking allows us to do, as opposed to like where like it gets more. Otherwise, you'd have to like hard code that scenario, and then not have a lot. But now we do that through our expression language stuff like that allows us to create that flexibility, even not to only transform this thing into this thing, but also transform something into something extra to actually create new things just off of other data, right? And I know it's kind of a subtle that one is really interesting one as well. Another one that's a really unique problem that I think we've done a really good job of solving is the idea of a single design creating multiple end items.
Yeah.
Which is like the idea, like the common example and the canonical example is going to be, use a fancy word there, canonical. Example of that would be sinks or things that have like multiple finishes. So you'd say like, I'm making this sink, it's made out of brass, it's made out of pewter, it's made out of stainless, whatever the different things are. But the design is fundamentally the same, right? It's like the same CAD design. We're just going to make it out of different materials. So, but you can't really do that in the ERP world. You can use maybe a configurator or something like that and do it that way. But generally, all those things kind of derive to different part numbers. So you have this like base design that then you have to say pewter, it's actually this part number. For brass, this part number. That's a classic case of transformation. I have one thing, I have to make multiple things. And that problem is really difficult with linking. It's like, because the whole concept of linking is I have some kind of one-to-one. I mean, I guess you could have a one-to-many, but it gets complicated. Whereas if you're transforming, you're like, well, actually, I need to create all of these things, but I need to switch out parts of it based on the fact that the raw material changes. So you have similar but different derivations of the same source data. Talking lets you do that. Linking does not.
That's a sophisticated use case, but I also just think about like some recent projects that I've been on or I've participated in where like, they don't have part numbers, right? They don't have traditional part numbers for whatever reason. or they're heavily, they have, creating a lot of new part numbers and need to look them up. And there's a lot of complexity around that bill of material that they don't know ahead of time. So you really have to have this kind of ability to look up data and make decisions based upon other attributes in the model. It's not as simple as, this part is on this bill of material in both systems.
Yeah, you like the logic, just the use cases around like how companies operate tends to be in real, like it's like when the rubber, everybody has a plan to get punched in the mouth type of thing, right? Or the rubber meets the
It's
road.
Mike Tyson. Yeah.
Yeah, Mike Tyson's like, oh yeah, all these things should be the same until they're not, right? And sometimes the inertia of change, like, I mean, obviously you want to use best practices, but some people just do things in certain ways and they've done it that way. And then and sometimes you have to meet them where they are with how they do things. And having our philosophy has always been promote best practice, but have the flexibility to deal with real life.
Yeah, that reminds me a lot of, I wish to speak that same thing when I was teaching, right? Like when I was teaching, to me, it's like a big part of what we do is helping people meet them where they are and get them value, get them value and get them, moved ahead, right? Improving their process or improving and say, really what you should be doing is X, Y, and Z. But the reality is like getting to where they need to be it's going to be very difficult. Similar when I was a student or I was a teacher, like I had some students, it's like, well, I'm going to teach them this foreign language, but they're struggling with like the basics of grammar, the basics of knowing their own language, right? They're struggling with their own language, much less getting them to speak and learn a foreign language. So what can you do? You got to meet them where they are and try to help them get better every day. It's not enough to say, well, you're not doing it right, do it this way, right? You have to find a way that works for them and then help them move them towards the best practice and making it easier to get to that best practice. Because as you know, like if it's difficult to get to that best practice, you'll never get there. But if you can help them make it a little easier to get there, you're getting closer to that ideal.
Absolutely. I mean, that's really what your strong beliefs held loosely is probably the best way I've heard it described is like, which is not mine. I think that was actually Reid Hoffman from LinkedIn, but it's a great quote. It can be applied to lots of different things. It's like, we have very strong beliefs about best practices and how they're done. But like at the same time, like, don't let it be the enemy of progress, right? You gotta be flexible. So by making so we also found that with the talking kind of architecture, it gave us both the best of both worlds. It gave enough flexibility to let people kind of evolve into the best practice, but it also wasn't restrictive enough to where it forced them to where like they couldn't get any benefit at all. Because there's a lot of I think we talked about this before. There's a lot of all
or nothing out there.
Oh my gosh, there's so much all or nothing thinking. I mean, I'm an engineer. I can say this. I'm this way. I mean, I'm very binary sometimes. Like it's either great or it sucks. It's like that's not the way the world works. So it's like
no,
yeah. So it's like you can, especially with software. Like I think I said this in another podcast. It's like if you're designing a bridge, 80% done bridge isn't great. It doesn't really work really well. So engineers by nature think of things like that. Like it's built a bridge. It was designed to hold all the stuff it needs to hold, or it falls down. That's true statement with bridges and engineers and stuff like that, like airplanes, all those type of things. Absolutely, cross all the T's, dot all the I's, do that thing. But when you talk about like process improvement or like automation or integration, there are levels, and 80% done is 100% awesome. It's like
that's it.
And you can get huge benefits by not having that all or nothing. So meeting people where they are and having flexibility to get them to the next level, and then having a plan to get them there to get the best practice is able to provide a lot more value than just kind of being dogmatic about it and then really forcing it that way.
That's a good mantra. I mean, I think any parent or teacher or anyone who works with people will realize like making improvements, incremental improvements is the way to go. And don't let perfect be the enemy of good, right? Get an improvement going. It's like the whole thing, like you're not working out today, but just get walking, right? Just take a walk every day. Yeah, you're not going to turn into Arnold Schwarzenegger, but it's small improvements over time, right? And so definitely get that going. Well, man, Scott, this was a great conversation. I really, these themes keep coming back in terms of engineering, integration, but also kind of, very representative of our thought process and all these things. So I want to say thanks everybody for listening. You can find us again, if you didn't know, at CADtalk.com. Subscribe to our podcast, on YouTube with video and anywhere podcasts are distributed, Apple Podcasts and Spotify. Subscribe to us on YouTube. I love seeing those subscribers there go up. Leave a comment if you want in the conversation. Leave a comment and say, hey, what you think about this in terms of some of those takes on descriptions or integration and how you've seen that. Mm-hmm. So on the next episode of the Integrate Intelligently podcast, I think we're talking about ERP a bit more, digging into ERP and how your ERP can be holding your business back, and what you can do about it. So before I let you go, Scott, any last words? Any big things coming up for you?
No, I think we're doing some trips coming up, but I just want to reiterate. I'm glad you said about the comments. I think bring the comments on. I'm sure people are not going to agree with everything we said, and we're always open to learn. I think learning is, like we talked about this in one of our early episodes, is the relentless reinvention or the continuous improvement is a mantra. We live by that. So we love to get your guys' feedback. If something like trigger a thought, or you had you have a good example of where maybe we might be wrong, or we could update our thinking, please leave a comment that shows the engagement. We really enjoy that. And we're just trying to get better, but this is what we've seen that works so far. So, it's not dogma, it's a discussion. So but love to see the comments, everybody.
Okay, Scott, we'll see you next time. And thanks everybody for listening and watching.